Hi everyone. First I would like to thank the organizers of the conference for allowing me to share my research, which is research on developing MFCC-CNN based voice recognition system with data augmentation and overfitting solving technique. So I'm going to talk about these points in this presentation. First, why do we need speech recognition system? The ever-increasing need for intelligent systems technology capable of enhancing human-machine interaction have become a very important topic. Voice recognition enhances the capabilities of computer in interacting with the humans. So the device becomes able to recognize, understand and interact with the content of words and phrases in a spoken language. The benefit of speech recognition system include interacting with robots, helping disabled people and controlling digital devices. And the application of such technology include hands-free technology, smart homes, voice print applications and voice assistant. So basically, sound is rapid changes in air pressure. The sound volume is determined by, or the sound amplitude is determined by how much pressure varies between periods of high and low pressure, while frequency is determined by how fast these changes are. The slide here shows a very brief history of speech recognition. The first speech recognition system, AIMEE, which is a single speaker number recognition system, was developed back in 1952. Just after 10 years, IBM introduced its first speech recognition system, which was able of recognizing 16 words. AIMEE was developed during 1970s, which was able to recognize 1011 words. In the 1980s, the hidden Markov model was applied to the speech recognition system, and in 2001, Google introduced the voice search application that allowed users to search for queries by speaking to the machine. And finally, in 2006, the use of deep learning in speech recognition was proposed. Most automatic speech recognition systems extract features from the acoustic signal instead of using the full speech signal due to the large variations in the speech signal. MFCC, male frequency substral coefficient, is the most popular and used feature extraction algorithm. The block diagram of the MFCC algorithm is shown here. The pre-emphasis increases the magnitude of the higher frequencies within the spectrum. Framing divides the acoustic signal into subframes, which are then multiplied by a window function. The fast Fourier transform is applied after that and squared because phase information is not helpful here. The next step is applying triangular bandpass filters to the signal in male scale. Then we use log, since the human response to signal level is logarithmic. And finally, discrete cosine transform is applied. The result of the conversion is called MFCC. An enormous amount of research has been done on the use of machine learning for speech processing applications, which has yielded much better result when compared to other methods. Deep neural networks have shown great improvement in speech recognition tasks. In this research, we have designed a convolution neural network in order to classify speech signals based on its MFCC features. The main application of CNN is image processing, but it has been used in many other fields like voice and video processing. CNN consists of convolution layers which extract features from input data, pooling layers that are used to reduce the dimension of the data, and fully connected layers that are similar to the multi-layer perceptron. This table shows the architecture of the used model. The dataset used in this research is a speech commands dataset released by Google in 2017, which contains almost 48,000 audio clips of 20 words like up, down, left, right, 0, 1, and so on. Since the duration of some recordings in the dataset is less than 1 second and the sampling rate is very high, pre-processing steps have been used. The first step is budding short clips. So short clips are not compatible with the system, so a function that adds 0 value to those files have been used to make the duration of all files 1 second. The second step is resampling. The sampling rate of the files was 16 kilohertz. So they have been resampled at 8 kilohertz since most speech-related frequency are at this frequency. The purpose of this study are to provide an algorithm that understands a small group of simple audio commands and to work to minimize number of layers in the architecture to maintain some simplicity within the model and minimize runtime. One of the biggest challenges when training deep learning models is choosing training time or number of epochs. So when choosing a large number, the overfitting problem appears. The overfitted model is not generalizable to never seen before data. However, if the number was small, the underfitting problem appears, which means that the model has not trained enough on the training data, so the performance is low and the error rate is high. To solve this problem, the following techniques have been used. Early stopping, which stops training the model before overfitting occurs. The model tries to chase the loss function crazily on the training data. By tuning the parameters, it keeps another set of data as the validation set. And as it goes on training, it keeps a record of the loss function on the validation data, and when it sees that there is no improvement, it stops rather than going all the epochs. The second technique is dropout, which is a recent introduced regularization technique in which randomly selected activation are giving a value of 0 during training, so that the model becomes less sensitive to specific weights in the network. This in turn results a network that have more ability to be generalized. Due to the small size of the available dataset, a data augmentation technique has been used, which increases the amount of data to obtain more data. Even though we have no more data, slight adjustments are made to the current dataset. The deep neural network will think that the new data is distinct from the existing data. Data augmentation was used in this paper by shifting the pitch of each audio file in the dataset, which led to double the size of this dataset. Pitch shifting is a method for making audio thinner or thicker. Figure here shows an example of pitch shifting by 2 octaves. The training was done with 32 batch size. 3 metrics were monitored to review model performance, accuracy, loss, and confusion matrix, because only tracking accuracy gives an incomplete picture of the model performance. Model accuracy is shown here. The accuracy was low at the beginning of training because the network was initialized with random weights. As the training process and iteration progress, the network begins to learn the features in the audio clips, so the recognition accuracy becomes greater. The training process stops at epoch 48 due to the early stopping technique. The highest accuracy value the best model has reached was 82.33% on the training set and 88.35% on the validation set. Model loss is shown in this figure, which monitors the value of the categorical cross-entropy function during the training process. The value of the loss function given by the best model was 0.573 on the training set and 0.557 on the validation set. And the last metric is confusion matrix, which is a well-known matrix in the field of machine learning, used to test the performance of a classifier and measure the effectiveness of a model by displaying the percentage of correct and incorrect classification. The last line in the matrix, for example, represents the results of classifying 945 zero words. The model recognizes 820 of them as zero. That means 86.77% accuracy. So the study showed that using techniques such as early stopping and dropout and data augmentation have helped solve the overfitting problem and make the model more able to generalize, which enhances the model performance. Moreover, this paper showed that the use of MFCC following by CNN model as a double phase feature extraction has improved the accuracy and reduced the complexity of the model. The future work will be on increasing the model recognition capability in noisy environment. And that's it. Thanks all for watching.